In this video, we will learn how to find compositional functions both graphically and algebraically. Let's start with the first example. And in this example, they're asking us to find or evaluate the function, and we would like to do that graphically. Even though they have given us the equations for f, g, and function h, I still want to look at the graph to determine what f of 3 is. So since they want f of 3, I look at function f. When they say f of 3, it means that x is equal to 3 and I need to find what y is. So I mark 3 on the x-axis and I find a point on the line having an x equals 3. And that point is 3, 0. So then the y is 0, so f of 3 is equal to 0. Now let's move on to example B. G of negative 2, it means that I have to look at the g function. And when g is equal to negative 2, it means I have to mark negative 2 on the x-axis, project that to the line, and find a point on the line where x is equal to negative 2, project that point to the y-axis, and then I can find that that point has an x value of negative 2 and a y value of 2, so g of negative 2 is equal to 2, which means that when x equals negative 2, y is equal to 2. Now let's move on to part C. H of 1, it means I need to look at the h function at this line. And when h of 1 means x is equal to 1 and I need to find what y is. So mark 1 on the x-axis, project that to the line, and find a point on that line having an x equal 1, and then the y is equal to 5. So h of 1 is equal to 5. Now this is simple evaluation done graphically, but now what happens when I introduce composition of functions? What does this mean? Now again, we're going to do this graphically. F of h of 2 means that 2 is the x value of the function h. So if you have something like that, the first thing you need to do is take h of 2, so think of the function on the inside. So take the inside first, find that, and then we're going to worry about the f. But now, first of all, let's focus on the h of 2. Now h of 2 means I need to look at function h, and I need to find what the y value would be if x equals 2. So when x equals 2, then the y is 2. So then h of 2 is 2 in this case. So when the input for function h is 2, the output is also 2 in this case. Now go to the function f, and now I know that h of 2 equals 2. So I plug in 2 for h of 2. So now the output becomes the input for function f. So think of this like a washer and a dryer. So first of all, to represent the clothes that you put in the washer, and then after you wash the clothes, you put the, let's say, wet clothes in the dryer. So think about it this way. There are like two-step process, okay, to get the job done. So 2 is the input for function h. You find the output, and then the output becomes the input of function f. So now just plug in 2 in function f. F of 2, now I look at function f. I try to find what the y value would be if I have an x value of 2. And that would be negative 4. So when x equals 2, that point will have a y of negative 4. So then f of 2 equals negative 4. Now always remember to end it with how you were asked the question. So f of h of 2 equals negative 4. Now you can choose to put brackets, or you can just simply write f parentheses of h of 2 equals negative 4. So it doesn't matter if you use brackets or use parentheses, it's the same thing. Now let's move on to part E. In part E, they're saying g of h of 3. I need to evaluate that. Now, every time the input is an actual number, the output at the end is going to be an actual number as well. So now the input for function h is 3. So I need to find the output when the input is 3. So let's go up to function h. And when x equals 3, let's project that to the line. And then the y would be -1. So the output is -1. So h of 3 equals -1. Now plug that in the function that is on the outside over here. So g now of -1, what would that be? Now let's go ahead and look at the graph of function g. And the input is -1. Then the output would be 4. So project -1 to the line and find what the output would be for that point, and it's 4. So then g of -1 is 4. So g of h of 3 equals 4, and that would be my final answer. So now let's see how we can do this work algebraically, okay? So f of h of 2, so remember that f of x equals 4x minus 12. H of x equals -3x plus 8. So remember, every time I want to evaluate, I start with the function on the inside, so h of 2. And I want to do the same work I did before, but algebraically. So that means I need to use the function of h, which is -3x plus 8, and I need to plug 2 for x. So -3 times 2 is a 6, plus 8 is a 2. Now I plug that in f, function f, which is the function on the outside. So f of 2. So now I look at function f, and I plug 2 for x. So 4 times 2 is 8, minus 12 is -4. So the final answer is a -4, and that's exactly what I found before when I did it graphically. Now g of h of 3, it's the same concept. Now keep in mind that g of x from before is going to be equal to 2x plus 6. Now I start with the inside function h of 3, and I look at the function h, and I plug in -3 times 3, so I plug in 3 for x plus 8, so -9 plus 8, that's a -1, and I plug that into the function on the outside, which is g, so g of -1, so 2 times -1 plus 6, which is -2 plus 6, which is a 4, so the final answer is a 4. That's how you do this work algebraically, and this is what you do when you have a number plugged into a function, and that output is plugged in of another function as well. Now, what do we do when a number is not given and you actually need to basically plug a function into another one? Now, I would like you to try C and D on your own. Now, the answer for C is 10, and the answer for D is -40. So try that on your own and check if you actually understand how to do evaluation when it comes to composition of functions algebraically, okay? Now let's move on to the topic. So the first topic was evaluating graphically. The second topic was evaluating algebraically when it comes to composition of functions, and now we have to do the work also algebraically, but now we don't have to evaluate. We just need to create the composed function, okay? So f of h of x, it means I need to plug function h into f. So ask yourself, what is function h? Function h is -3x plus 8. So now the whole idea is now I need to look at function f, and I need to plug in -3x plus 8 for x. So I need to replace x by -3x plus 8. Okay? Just like the idea when you have f of 2. So you replace x by 2. So f of all of that, so all of this, get plugged in for x. So now you have 4 parentheses minus 12. So this is the function f. And inside the parentheses, I need to plug the function h, which is -3x plus 8. Okay, so the h gets plugged in f, because h is inside f, okay? So 4 times negative 3 is negative 12x. So now I try to distribute and simplify my new function. And 4 times 8 is a 32 minus 12, so that's negative 12x plus 20. So then f of h of x is basically negative 12x plus 20. So when you have an x as an input on the inside, the final answer is going to be an actual function and not a value, a number. Okay? So now let's move on to h of f of x. So that means I need to plug f into the function h. So let's look at function h. It's negative 3 parentheses plus 8. And what do I need to plug in these parentheses? So h of f of x means h of 4x minus 12. So that means I need to plug in 4x minus 12 for x. Okay, you got the idea? Now let's distribute and simplify. So negative 12x plus 36 plus 8, and that's negative 12x plus 44. So then h of f of x is equal to that. Now we try to find f of h of x and h of f of x. So are they exactly the same answer? No, they're completely different. They're different functions. So if you plug a function into the other and you just change the order, you're going to have different answers. Okay? Keep that in mind. When do we have similar answers? And that would be our next lesson, but not this lesson. So I want you to keep in mind that in general, f of h of x and h of f of x are completely two different functions. Now go ahead and try C and D on your own. And let me give you the answer so you can check. So g of h of x is negative 6x plus 22. And f of g of x is 8x plus 12. Now let's move on to number 5. In number 5, they're saying that h of g of x equals 32. And they want me to find x and then write the solution of the composite function. Okay? So they want me to find what x would be if h of g of x equals 32. So now to do this, I first of all need to know what is h of g of x, find that, simplify it, and then set it equal to 32. The only variable is going to be x, so I can just simply solve for x. So let's find what h of g of x is. So that means it's h of, what is g of x? 2x plus 6. Now look at the function h. Function h is negative 3x, so open parentheses and close them. Leave some space so I can plug in 2x plus 6. And then don't forget the plus 8. So h is negative 3 parentheses plus 8. G is 2x plus 6, so you plug g in for the value of x. Now distribute, so negative 6x minus 18 plus 8, and that's going to be negative 6x minus 10, and that is h of g of x. Now I just found this left side. Now I need to set it equal to 32 and find what the x value is. So negative 6x, add 10 to both sides, so you get 42. Divide by negative 6 to find x, and that's negative 7. So I just found x. Now I need to write it as an ordered pair. And the ordered pair, x is negative 7. Now 32 is equal to h of g of x, so that is my y. So y is 32. Okay? Now go ahead and try number 6 on your own. The ordered pair that you're going to find at the end is 336. Now, if you're not getting these answers and you still have questions, remember to go to any Algebra 2 tutorial to ask some questions.